Good morning. Wanted to do a quick video on routing information protocol. What is it? How do we configure it? So if you're interested in routing information protocol, the Network Plus, the new Network Plus N10-008 has RIP on it. The CCNA 200-301 does not have RIP on it, but you should know it. If you're working towards your CCNA, you should know about RIP. You should know how to configure it, even though it's not on the test. And then if you're working for that Network Plus, it's on the Network Plus as well. I'll cover all the information you need to know for that exam here. So let's get into it. Routing Information Protocol, also known as RIP. It's a dynamic routing information protocol. It's a dynamic routing protocol. And what do dynamic routing protocols do? So they do a couple different things. One, they choose the best path from source to destination. And two, they advertise that path. So the way routing information protocol works is if I established RIP on all these routers right here, the routing information protocol would find the best path based off of the number of hops. And a hop is simply a jump from one router to the next. So let's say all these routers have RIP on it. Router 2 wants to communicate to router 4. So the way that it works, if you have RIP on all these routers, it'll count the number of hops. So this path right here, 1, 2 hops. What about the other path? Let's try that. 1, 2, 3 hops. So this path here, the path with the least number of hops, would be chosen as the route. So routing information protocol is typically used on small to medium-sized networks. The reason for that is because the maximum number of hops is 15. So if we had 15 hops here, 1, 2, 3, 4, all the way to 15, on that 16th hop, the host would be considered unreachable. So that's why we use RIP on small to medium-sized networks. It's a little bit older of a dynamic routing protocol, so it's not as efficient as, let's say, OSPF or EIGRP, but it still has a place in networks. So how do we configure it? All right, so let's go over to this network here, and we'll go into router 0, and we're going to go into the CLI. I'm going to show you how to configure RIP. So we're in the CLI. We're going to go into global configuration mode, and you don't have to go into the interface. All you have to type in is router and RIP. Router space RIP. That's it. That's all you got to type. And then what you need to do is just add the networks that are directly attached. So we have this network here, 192.168.1.0, and then we have this network here, 10.10.10.0, and we're going to add those networks. So network 192.168.1.0, no subnet mask needed, and the next network, 10.10.10.0. Just like that. It's that easy. And we'll exit out of this, and we'll go over to router 1. So we'll go over to router 1, get into the CLI, go into global configuration mode, and the same thing, router space RIP. Then you type in the network. So you attach the directly attached networks, not a network down the road, directly attached to the router. So that network is 10.10.10.0. This network right here, 10.10.10.0. And this network right here, network 172.16.1.0. Just like that. And the way routing information protocol works is it sends, like I said, it determines the best path. And how did we figure that out? It does it by hop count. The best path is determined by the lowest number of hops. Then what else do dynamic routing protocols do? They advertise their routes to other routers. So this router, router 0, will send its routing table to this router here because it's also a RIP router. And that's the way RIP works. It sends its entire routing table every 30 seconds. So let's go into router 0, and I want to show you something. We're going to do a show IP route. And you can see right here where it says R stands for Routing Information Protocol. And we have our network, 172.16.0.0. You can reach that network via 10.10.10.2. So if router 0 wants to reach this network, it will go through 10.10.10.2, this interface right here. So it worked, right? So what are these numbers here? So 120 is the administrative distance of the routing information protocol. Every dynamic routing protocol has an administrative distance. So an administrative distance is essentially the trustworthiness of that route. So EIGRP has an administrative distance of 90. OSPF has an administrative distance of 110. So if we had multiple protocols on these routers and they were all displaying the same route, the way that route would be chosen is based off of the administrative distance. So if we had EIGRP, which would be annotated as a D here, with the same path to 172.16, that network, then EIGRP would be chosen over RIP because EIGRP has a more trustworthy administrative distance. It has a lower administrative distance of 90. So RIP has 120, which is relatively high. So if you had OSPF on there, OSPF would get chosen over RIP because OSPF has an administrative distance of 110. So what's this one? This one is called the metric, and the metric for RIP is the hop count. So if we look here, router 0 to router 1, one hop. It's it, just one hop. That's what that number is. That number is the number of hops to the destination. And that's it. It's that easy. That's routing information protocol. That's how you configure it, and that's what it does.